Así que dale pom 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 pom, ponle carne a mi sazón, son, chócate eso con mi bom bom.
Hi everyone, we are students of Chemical Engineering UNIKL and MICET UNIKL.
We will be having a talk show for our group assignment in subject named Introduction to Biochemical Engineering Technology.
Stay tuned.
Good morning and hi everyone. For our talk show today, we will discuss about a scientific research entitled Enzyme Action and Enzyme Immobilization Technology. Before we further discuss about our main topic today, I would like to explain and define to you about what is meant by enzymes. Enzymes are proteins that act as catalysts within the living cells. Catalysts increase the rate at which chemical reactions occur without being consumed or altered permanently at the end of the chemical reaction. Hi everyone, welcome back to our talk show today about scientific research entitled Enzyme Action and Enzyme Immobilization Technology. To discuss more about this topic, I bring to all of you my very special guest for today. On the very left of me, we have Dr. KAMILAH binti MOHAMAD. And my left side will be ALIA binti ARABAIN. In the first place, before we proceed in discussing more about the main topic today, I would like to talk a little about enzyme immobilization. It is defined as a process confining the enzyme molecules to a solid support over which a substrate is passed and converted to products. Or in other words, it is one whose movement in space has been restricted either completely or to a small limited region. Okay, why we need enzyme immobilization? Okay, Dr. NIR, you can correct me if I'm wrong. Okay, this beyond my knowledge. So, okay, as far as I know, enzyme immobilization is a must to enhance stability, easy separation of the enzyme from the product, and to protect from the activation and degradation. Okay, we have many examples of enzyme immobilization in this work, and one of it is absorption process. It involves the physical binding of the enzyme on the surface of carrier, which may be organic or inorganic. And the process of absorption involves very weak interaction like hydrogen bonds. It also has advantages and disadvantages for the absorption process. As for the advantages of the absorption process, it can be recycled back, simple and economical. While for the disadvantages, it exposes to microbial attack, relatively low surface area for binding. To discuss more about the example, many more examples about enzyme immobilization, I would like to invite ALIA to explain more example, one or two example of chemical process of enzyme immobilization.
Okay, thanks for our MC today. And I would like to explain regarding chemical process for enzyme immobilization. It would be cross-linking, which involves intermolecular cross-linking of enzyme molecules in the presence or absence of solid support. This method produces a three-dimensional cross-linked enzyme by means of a multifunctional region that links covalently to the enzyme molecules. There are several advantages and disadvantages for cross-linking process. Firstly, I would like to explain regarding the advantages such as very little absorption and higher stability either in ionic and substrate concentration. As for the disadvantages, cross-linking may cause significant changes in the active site, and also it could be not cost effective compared to the other.
That's all for enzyme immobilization. We will take a break and come back with many more knowledge regarding our main topic today. Welcome back to our talk show about enzyme action and enzyme immobilization technology. Okay, due to the current demands of sustainable green technologies, the use of enzymatic has increased in industrial processes. I would like to ask opinion from Dr. KAMILAH BINTI AMIN regarding the technology attached with the industry.
Okay. First of all, employment of enzyme as biocatalyst offers the benefit of coagulations, biodegradability, and catalytic efficiencies. But in industrial process, the process can be harm to the enzyme. Hence, this can increase the propensity of enzyme destabilization, shortening the industrial lifespan. So the technology of enzyme immobilization find a way now how to cope this problem by enhancing enzyme catalytic properties, simplify downstream processing, and improve operational stability. This immobilization of enzyme is very useful in environmental, food science, biotechnology, pharmaceutical, and petrochemical applications. So the industrial applications of the immobilized biocatalysts are: first one is food industry. Immobilization of this enzyme has been recognizable for commercial because immobilization improves yield of food processes and reduces the process cost. For instance, the starch liquefaction process is using alpha aminase, which this enzyme is immobilized into ion exchange resin beds for better stability and time required to process. If not, the enzyme will suffer long-term operational stability and difficulty in recovery.
We would like to add on with some more examples regarding the immobilization technology attached with the industry, and I would like to some more focus on our industry in Malaysia.
Okay, let me proceed with the immobilization technology attached with the industry in Malaysia. Especially, there is a lot of industry using enzyme immobilization techniques such as pharmaceutical, especially it focus on more on the production of penicillin, and the enzyme that will be immobilized is penicillin G acylase in a macromosporous silica sphere with a micro device. This enzyme will be placed in a packed bed reactor in order to perform penicillin G production.
Okay, such an interesting point that had been elaborated by our two panels here. And guys, we will take a second commercial break, and we will come back with our last point to describe and to explain more details about the future of immobilization techniques, which will be more focused on Malaysia. Hi guys, we meet up again, and this will be our last session in discussing our scientific research regarding enzyme action and enzyme immobilization industry, that we more focus on Malaysia. Okay, the last one will be the future of immobilization technique that maybe can be used in our industry in Malaysia, right?
Yes.
Okay, in the industrial biotechnology, the skill to prepare the immobilized enzyme with stability has proven to be one of the key steps in rendering an enzymatic process that is economically viable. Availability of the immobilized enzyme biocatalyst with improved activity and stability is also expected to reduce the expense of products. If properly designed, enzyme immobilization can be a very powerful tool to enhance almost all enzyme properties, for example, activity, stability, specificity, and selectivity, and also reduction on inhibition. Due to the above advantage that I mentioned earlier, enzyme immobilization has been a focus for biologists, chemists, and enterprises. Thus, we would like to further discuss regarding several cutting-edge techniques used in the future of the enzyme immobilization technology. So now, let's proceed with the explanation of future enzyme immobilization technique by ALIA.
Thank you for giving me a chance to talk, to explain regarding new technology for enzyme immobilization. So I would like to propose first would be microwave irradiation technique, which in the immobilization, especially in porous support, enzyme molecules are difficult to distribute throughout the porous carriers because of diffusion limitations, and they often remain only on external channels using non-microwave assisted protocols, which are currently the methods of choice for immobilizing enzyme. The mass transfer is even slower for enzymes having large dimensions, such as penicillin acylase. The immobilization of such enzyme to porous material can prove tedious using conventional method. So, microwave irradiation can be applied in the immobilization of enzyme for the mesocellular siliceous forms enzyme, which can be called as MCFs. For an instance, microwave irradiation technology can be used to immobilize papain and penicillin acylase into mesocellular siliceous form. Time for immobilization will be decreased significantly and the enzyme loading can be dramatically improved.
Thank you, ALIA BINTI AMIN. I would like to ask Dr. KAMILAH and MOHAMAD would like to propose some new techniques that can be applied in our industry in Malaysia.
Okay. I think there is some more that I want to add. The technology, the future technology for the immobilization technique that we could apply is single enzyme nanoparticles. So industrial biotechnology is consistently seeking improved enzyme performance and stability under harsh conditions, found in most industrial process to decrease cost. So as an innovative way of enzyme stabilization, single enzyme nanoparticles (SEN) technology was rather attractive because enzyme in the nanoparticle exhibited very good stability under harsh conditions. So by developing armored single enzyme nanoparticles (SEN) that surround each enzyme molecule with a porous composite organic or inorganic network of less than a few nanometers thick. This approach can significantly stabilize two types of proteases such as chymotrypsin, and trypsin. So the armor network around the chymotrypsin is so thin and porous that a large mass transfer limitation on the substrate could not take place. So to simplify the versatile preparation that yields a single enzyme capsule with enhanced stability, high activity and uniform size can be achieved by using two-step procedure, including surface aquilydation and in situ aqueous polymerization to encapsulate a single enzyme in nanogel to provide robust enzymes for industrial biocatalysis. For thermally stable enzyme, the route may be good immobilization strategy because enzyme load on the outer surface and the inner diffusion limitation of substrate and product could be avoided.
Oh, that's so very interesting elaboration for our two panels. Okay, before the closing session, I would like to give a short conclusion regarding our main topic here, titled enzyme action and enzyme immobilization technique. May I conclude?
Yes.
Okay. So, guys, overall, enzyme-based strategies are increasingly favored over the conventional chemical methods in industrial processes. Utilization of immobilized enzyme as biocatalysts will continue to attract significant attention from the industry as the technique is highly efficient, environmentally friendly, and can be potentially be cost-saving when further research is done to seek out or manufacture new matrices that are cheaper and more robust, which can be used as support for enzyme immobilization. To my two panels here, which is Dr. KAMILAH and ALIA BINTI AMIN. Thank you for coming to my show today and having a discussion about the scientific research about enzyme.
You're welcome.